Hello, wilderness explorers. Today we're going to talk about more properties of logs. This last video we spoke about how to convert from exponential to log format and from log to exponential. But now we're going to dig a little bit deeper into the woods, and we're going to look deeper into logs and what are some properties of logs. So let's get right to it. When you first cut up a piece of tree, right? When you cut it down, there are several properties you want to look at. Inside, you'll find rings. These rings will actually tell you the age of that tree, depending on how many rings. And I'm just kidding. We're not going to talk about these kinds of properties of logs. We're going to talk about different kinds of properties of logs. Of course, logs of functions. That was a bad joke. Anyway, I want to quickly review with you some exponent rules that we did before, because these rules will actually come in very handy, and I want you to be able to make connections between what we've done before to what we will do now. We spoke about the product rule, we spoke about the quotient rule, we spoke about the power rule, we spoke about these different properties, and they're actually going to come back into play. What I want you to come back into, or the connection I want you to make, is that when you're dealing with product, we're going to be talking about addition. When we're dealing with quotient or dividing, we're going to be associating it with subtraction. And when we're doing the power rule, we're associating multiplication. So if you can remember these three associations, adding, subtracting, and multiplying, then you're just going to convert these rules into logs, and it'll sort of help you remember these properties more. So let's start with the product rule. As you see here, we have some sort of log with some sort of base, and two things are being multiplied. When you multiply them, we can separate this into two separate logs. One with the first value of x and the second with the value of y. And we're going to be able to add them. You're able to separate these two quantities by adding them. And vice versa. You can combine two separate logs into one log. If they're adding them and they have the exact same bases, you can multiply what's inside the parentheses and put it together in one. That's what's so powerful about this equal symbol, right? The equal symbol goes both ways. The left equals the right, and the right equals the left. It's one of the most powerful symbols in mathematics, equality. Anyway, I don't want to get too emotional about my symbols and how I feel about them, but let's start doing some examples. And we'll do some examples. We're going to go back and forth so you can see how to expand it into a longer notation and how to condense them and bring it into smaller forms. All of these properties are going to be very important for next week. We're going to talk about how to solve equations of logs. And in order to solve them, we first have to be able to convert from exponential to log and log to exponential. Once we're dealing with logs, we've got to be able to manipulate the log and do whatever we want it to do based on these different rules. All right, let's get started on the first example. So here we have, as an example, log, let's call it some sort of b, log base b of 3x. Right? Notice how you're multiplying the 3 and the x. So what I can do is I can separate this, I can expand it, and I'm going to give it the same base for both of them, log base b of 3, and I'm going to add it to the log base b of x. I separate what's inside the parentheses into two separate logs, and I separate them to two different logs. As long as they have the same base, right, they are considered like terms. Let's go the other direction. Let's say that I give you log base b, as an example, of 3 plus log base b of 7. Here, I want to condense it. This is an expansion form example, and now we're doing a condensing. We're going to bring it together. Because we have the same bases, we're considered these two logs are like terms. So to combine these two logs, we're going to multiply what's inside, and that's going to give us log base b of 3 times 7. Sometimes you can actually multiply them. Sometimes there are going to be variables involved. If you can multiply and simplify, go ahead and do that. of 21. And that would be my solution. So notice how here we are expanding into a longer form by separating things, and then here we're going to take this expansion and we're going to condense it to something smaller. This is how you combine like terms and logs using the product rule. Here we're going to do the quotient rule. I'm going to do two examples again. We'll start with the quotient of 7 and x. So we're going to take just the log, say base 10 of 7 over x. Because it's base 10, I don't have to put a base here at the bottom. It's implied that there's a 10 right here, right? So I don't have to put it because it's base 10. Notice how through division, we're going to be using subtraction. When we divide in the quotient rule, just with the exponents, we're going to subtract the two different logs. So we're going to take the numerator minus the denominator. And that's basically it. Log base 10 of 7, or log of 7, minus log of x. Let's do an example where we condense it. This is expanding. Let's condense it. Let's say that we're given log of 5 minus log of 10. We notice that these two are like terms because they have the same bases. They're both base 10. So to combine these, we're going to divide them. 5 minus 10. To combine these logs, we're going to be able to divide them and say log of base 10 of 5 divided by 10. Because these have common multiples, we're going to be able to simplify this to log of 1/2. All right, let's move on to the next rule. Here we have the power rule. The power rule is very powerful in the way that you can take an exponent. We can take this exponent and we're going to bring it into the front and we're going to multiply it. Right? So we take this exponent, bring it to the front, and vice versa. We can also take something that's in the front and bring it upward so that you can have a log combined with another log. And I'll show you some examples here. So the first power rule example, let's say that we have, let's say that we're dealing with a natural log. So log base e. Natural log of, say, 2 to the 8th power. The power rule says that I can take this exponent and bring it to the front. So I can say it's 8 times the natural log of 2. The power rule allows you to take an exponent, simplify it by bringing it to the front as a coefficient. Now let's go the other direction where we're going to condense it and bring it in backwards. So let's say that we have instead x times log of 2. We're going to take this coefficient and bring it back up and make it an exponent. Log, oh, that was kind of sloppy. Log 2 to the x power. So being able to manipulate these going back and forth is going to be huge, again, when we start solving. But for now, I'm going to do a few more examples of these 3 different rules of expanding and condensing them. So if you would like to see more of this, continue watching this video. If this was enough, then go ahead and get started on the homework. I'm going to do some more examples in the video that combines properties, like combines the power rule and the quotient rule, or combines all of these rules together. So a little bit more complex. So expanding logs. Here we have multiplication involved in the top, 3 times x, and then divided by 5. We have a log going on. Let's go ahead and expand it into the most possible. Let's start with the division part. Because there's 2 terms in the top, I'm going to leave those 2 together, and I'm going to start by saying log base 7 of 3x, and I'm going to subtract the log base 7 of 5. I'm subtracting because we are dividing these 2. The numerator and the denominator can be separated by subtraction. Now in here, I still have multiplication, so I can still expand that even further. I'm going to title it here quotient rule. In the next step, I'm going to separate these two that are being multiplied, and I'm going to do the product rule. So I'm going to separate the log base 7 of 3 and the log base 7 of x. I'm going to separate these two by adding an addition symbol in there, and that's a product rule. The rest I just go ahead and bring down. It's log base 7 of 5. And this is called the power rule. Sorry, the product rule. Now that I have individual terms in every single one of them, I have expanded this as much as possible. So this log base 7 of 3x divided by 5 is the same thing as saying log base 7 of 3 plus log base 7 of x plus minus, log base 7 of 5. Notice how all three logs have the same base, which is why they're all connected together. In this next example, we're doing, again, division, but here notice how there's an exponent, so we're going to combine this with another property. So let's start with the division part first. Here we have log base 10 of x squared minus log base 10 of 4. Here we use the quotient rule by subtraction. And now, because I still have an exponent, I'm going to take this exponent and bring it to the front by using the power rule. So I take this 2, bring it over to the front. I'm going to multiply. So I have 2 times log base 10 of x minus log base 10 of 4. And here we used the power rule. The more you do these, the faster you're going to start getting into doing this. Here we have a natural log. Here we're going to use all the properties. We have multiplication, we have exponents, and division. So let's start with division. And I start with division because in the top, these two are connected. So because there's more connected, I'm going to do what's simpler. There's two terms, treated as two different things. So I have the natural log of 4x squared minus the natural log of 9. Here we use the quotient rule. Here next I have multiplication. So I'm going to do multiplication first and then the power rule later. So let's start with the quotient, the multiplication part, the product rule. I have the natural log of 4 plus the natural log of x squared minus natural log of 9. This is the product rule. Some of you might be tempted to do all of this at once, and you might be able to, but the tricky part is using this this quotient, product, and power rule all at the same time. So like, where does this 2 end up in, right? This 2 will end up in front of this natural log. So the natural log of 4 stays the same. Using the power rule, we're going to bring the 2 into the front as an exponent. 2 times the natural log of x minus the natural log of 9. And this one was the power rule. So here's probably the hardest version of expanding, where you get to use all three rules in the process. Now let's go the other way around, where we take the longest process, right, as we have here, and we're going to condense them using all the different rules. So our goal is to go back and to make it as small as possible by expanding it, by condensing the terms. So let's go from left to right. What do we see first? Okay, so I see that they all have common bases of 5s. So I'm going to be able to combine all three terms. If only 2 of them had 5 and this one had a base of 7, then I can't combine all of them. I can only combine the like terms, and those are going to be the ones with the same bases. So because they have all base of 5, I'm going to start with from left to right, starting with addition. Addition means I can combine these by multiplication, so 7 times 10. And that's going to give me log base 5 of 7 times 10, which is 70 minus log base 5 of x. And here we did the product rule. The next rule that we have is subtraction. So we're going to be able to divide these two. And we can say log base 5 of 70 divided by x. And here we have the quotient rule. A thing we do want to be careful with is here. I don't know if you can see it, but this is technically supposed to be the line on your paper, right? The 5 is right below it as a base. So this might be a little crooked, but this 5 should be below it. So make sure that your bases are below your line. It's below it. B for base, B for below. And then everything else is inside on the same line. Okay? Let's start here with the next rule. Notice how they all are natural logs. So we know that we're going to be able to combine all three terms. But before we can combine them, you can only combine logs or natural logs if there is no coefficient. So this 1/2, this 2, and this 1/2, they gotta go. We can only combine logs when they're in log format with nothing in the front. Okay, so let's use the power rule to move this 1/2 to the top, this 2 to the top, and this 1/2 to the top. So let's do the power rule with all of them first. This 1/2 goes as an exponent, the 2 goes as an exponent, and the 1/2 goes to as an exponent. And we have the natural log of x to the 1/2 plus the natural log of 3 squared minus the natural log of 9 to the 1/2. If we recall from rational exponents, whenever we have something to the fraction, it's going to be some sort of square root. Because we have 1/2s on both of those, are really just square roots. Square root formats, right? So I can rewrite this as the natural log of the square root of x plus the natural log of 3 squared, which is 9. Let's go back. Minus the natural log of the square root of 9, which is 3. Right? So I can rewrite this as the natural log of 3. Now that I have a 1 as a coefficient, right, in front of the natural logs, now I can start combining the logs together into one format. So let's start with the product rule. Let's start with multiplication. Because it's addition, we're going to be able to multiply this term and this term. Now notice how one's in the square root and one of them is not. So you can't combine them into one square root. One's going to have to stay on the outside and one will have to stay on the inside. And it comes down like this. We have the natural log of 9 radical x. They're just multiplied together. The number looks better in the front than versus in the back. And then we subtract the natural log of 3. So here we use the product rule. Product rule. Here we use the power rule. I forgot to write this. And here we'll just simplify. All right, to combine these next two terms, because of subtraction, I'm allowed to divide this term and this term. And I'm left with the natural log of 9 radical x divided by 3. And this is my quotient rule. Because these two are like terms, this 9 and the 3, I can actually simplify this and divide it. And I can cancel this out with a 1 and a 3. So if I simplify this a little bit, I'm actually left with the natural log of 3 radical x. And that's just through simplifying. And here's my solution. All right, this is going to be our last example. This is the most complex example that I can think of because I added parentheses and power rules and more different things involved. So let's go ahead and get started. I cannot combine any of these logs. Again, these are all like terms. They have the same bases, log base 10, base 10, base 10 technically. I can't combine any of these until they don't have anything in front. So they have to have just the log. The 3 has to go away and the 2 has to go away. So let's start with that. I have 1/2 bracket or parentheses log of x to the 3rd power, right? And the 2 will also go to the top, minus log of y minus log of z squared. I like to write that on the rule that I'm using because it reinforces that I know that each step has an explanation. I don't just get there by magic. Every step that I do in mathematics has a meaning and has a purpose. And if I don't have an explanation for that step, then something's probably going to go wrong. All right, now that I have these in no coefficients in the front, or as 1 is the front, I can start combining these using the product quotient rules. The 1/2 stays on the outside, so I'm going to leave the 1/2. And then I'm going to start by combining using the quotient rule subtraction. So I have log of x cubed divided by log of that y. That was a quotient rule. Now I'm going to continue with the quotient rule again, because it's subtraction. I get to divide this divided by this. Now, if you remember back to dividing fractions or dividing two things, when you're dividing with a fraction, you want to be able to multiply by the reciprocal. All right, so I really just have, let's make this a little smaller, or move it up a little. Whoa. Shrink this a little bit so I can make more space. Let's say I want to divide these two, so I have the 1/2. Technically, I have the log of the first term, x cubed over y, divided by z squared. Now, this looks a little crazy, right? But dividing by that number is really just saying x cubed over y times the reciprocal, 1 over z squared, right? Dividing can be the same thing as multiplying by the reciprocal. And then this just comes down to x cubed divided by yz squared. So I'm going to write this in that format. 1/2 parentheses or brackets of log x cubed divided by z squared. And here we did the quotient rule again. Now, for this very last step, I have a 1/2 in the front of the log. I'm going to be able to do the power rule one more time and put it in the top. So I have, let's make this smaller again, make some more space. So I have the log of x cubed over, what happened to this y? Sorry, there's supposed to be a y right there. I forgot that y. yz squared to the 1/2 power. If you remember, to the 1/2 means the square root. So let's first call this the power rule. And then lastly, I'm going to change this into square root form. So I'm going to write it as the log square root of x cubed over yz squared. These two are equivalent in their ways. Either one will be acceptable. But you definitely don't want to have the 1/2 in the front, right? This 1/2 in the front is not simplified. The log by itself, everything move out of the way, will get as close and as condensed as possible. All right, guys. Well, I hope this helps. I try to give you examples that are simple all the way to complex so that they're easier to understand and do with the homework assignments. Let me know if you need anything. The end is almost near. And don't forget to send me an email. I'm about to put another video together with the Ask Me Anything. All right, guys. Calculator.